Well, so now it is clear that how to differentiate between anomers. So anomers are related to the uh, first stereogenic carbon in both the cases, whether it is aldohexoses or ketohexoses, because this is the first stereogenic carbon here, not C1 first, right? C1 is this, but here when we say first means the first one which coming, not number one, not C1. So this is the first stereogenic carbon, this is second, this is third, and this is fourth. So in fructose, N is equal to what? 4. N is equal to 4 in cyclic structure. In cyclic structure. Right? So it is now it is clear how to name alpha and beta. Now another concept that is very important, and that is reducing and non-reducing sugars. Reducing and non-reducing sugar. Non-reducing sugar. So reducing and non-reducing sugar. This is related to the oxidation of sugar with the tolerance and failing solution. So reducing sugars, they reduces the tolerance or failing solution or Benedict solution, and itself oxidizes. See again, listen carefully. Reducing sugars reduces tolerance reagent or failing solution, right? So reducing sugars reducing sugars reduces reduces uh, the tolerance reagent or failing. I have already talked about tolerance, what is tolerance reagent, what is failing, so I'm not going to discuss here. Failing solution. So reducing sugars reduces the tolerance or failing, right? Tolerance reagent or failing solution, and itself they oxidizes, right? And itself itself oxidizes, itself oxidize, right? So those sugars which reduces tolerance and failing. So if you remember the chemistry, you are well aware that aldehydes, they reduces tolerance reagent and failing solution, Benedict solution. Ketones, they are not able to reduce tolerance and failing solution. So in sugar, in cyclic structure, if you see if you have open chain structure, then you can very easily identify, okay, this is aldose hexoses or aldo sugar. So aldo sugars have aldehyde group, so they are reducing in nature, right? But fructose is a keto sugar. So fructose is a keto sugar. It has ketonic group, and in the main chemistry, all of you have studied that okay, ketones do not reduces tolerance and failing solution. So, which type of sugar you are classified? Fructose. Obviously, you will classify in the non-reducing sugar, but you know, fructose is a reducing sugar. Fructose is a reducing sugar despite having ketonic group, right? So, how to define reducing and non-reducing sugar? And you can define best in reducing and non-reducing sugar best in cyclic structure. Don't see open chain structure, right? I will explain how fructose reduces tolerance and failing reagent. But you know this. In the cyclic structure, by just simply seeing the structure of carbohydrate or sugar molecule, you can very easily identify whether it is reducing or non-reducing, right? So I am giving you a very important point, how to identify reducing and non-reducing sugar by just observing the cyclic structure of that molecule, right? See, this is very, very important point. If anomeric OH, all of you are knowing what is anomeric carbon. Anomeric OH, anomeric OH is blocked. Blocked means, what is the meaning of blocked? Blocked. Blocked means it is in the form of OR or in the form of this, right? Means OR is there, OCS3, OC2H5 or like that, or this type of some other group is attached here. So such type of sugars are non-reducing. Non-reducing, right? And and such type of sugars are named as a suffix oocyte. This suffix is added. So there are, many ways to identify. Okay, if it is only written the name, if in the name oocyte is coming, means its anomeric carbon is blocked, and this is a non-reducing sugar, right? And obviously, opposite of this, if anomeric OH is free, if anomeric OH is free, then reducing, then reducing, right? So this is a clear concept, and in this case, suffix we are adding OSE, right? Now see, you have structure fructose, fructose structure. Identify the anomeric carbon. So the anomeric carbon is this, carbon number 2. This is anomeric, right? OH, anomeric OH. Don't see CH2OH. Anomeric OH, free in the form of OH. So this is what? Reducing. Where this keto group is there? Nothing. In cyclic structure, there is no keto group. So if, right, if you have anomeric carbon, OH is free in sugars, then this is reducing. Or you can, one more thing you can say, which type of linking, which type of functional group is there? This is when one is ether linkage, other is OH, so hemiacetal. So you can say when this OH is free, anomeric OH is free, means this is the in the form of hemiacetal. Hemiacetal. So if there is a hemiacetal type structure is there, in the cyclic structure, then this is reducing. And if it is blocked, then anomeric OH is blocked, means it is acetal. Suppose that examiner some at some point of time examiner has given you the structure like this, OH and OR like this. If examiner has given structure like this and ask, okay, tell whether this structure is reducing or non-reducing. Whether this structure is reducing or non-reducing. Then what? How to answer this? What you have to do? This is a hemiacetal. This is the hemi. This is not sugar. Suppose that this type of structure is given. H is there, O is there, and not six-membered ring. This is only five-membered ring. This type of structure is given. Suppose that. Okay. So, and it is asked, tell whether this will reduces tolerance or failing reagent or not, give tolerance test or failing test or not. So identify, see, this is ether linkage, this is alcoholic linkage, so this is hemiacetal. And if it is hemiacetal, then tolerance test positive, failing test positive, right? So not only carbohydrates, if any organic compound in the similar structure, if it is in the form of hemiacetal is there, then definitely this will show the tolerance and failing, means reduces the tolerance and failing reagent, right? So in this way you can identify the reducing and non-reducing sugar by just observing the structure. Okay, good. Now see, let's do some problems based on this. Now see, determine whether each of the following disaccharides is a reducing sugar, right? So one by one you have to identify. See, this is aldohexose cyclic structure. See, this is carbon number 1, this is carbon number 2, this is carbon number 3, this is carbon number 4, this is carbon number 5, and this is carbon number 6. So 1 and 5, I am giving you different answers, not only reducing and non-reducing, and different observations as well. So if you see, this bond is moving this side. This is moving this side, same side as carbon number 5. So this is which anomer is this? This is beta. This unit is beta. And what about this unit? We will see this orientation or this orientation, anomeric, to decide. Obviously anomeric, not this. Don't see this linkage to decide alpha and beta. You will see this linkage anomeric. Anomeric carbon is this 1, 2, 3, 4. Fourth carbon is not anomeric. So whatsoever the orientation, that hardly matters. 5, right? So this is anomeric carbon and it is the same. So this is also beta. So in first structure, both the units are beta anomer. This is beta anomer and this is also beta anomer, right? This linkage, this linkage is known as interglycosidic linkage. You know, this linkage is called interglycosidic linkage. This is called interglycosidic linkage. Now, whether it is reducing or non-reducing, can you tell me this is acetal or hemiacetal? So see, O ether linkage. So this is acetal. Now tell me, this is as hemiacetal or acetal? So this is hemiacetal, right? So is this sugar is reducing or non-reducing? What concept I have given you? See, for reducing, anomeric OH is free. So this is a disaccharide. Two units of monosaccharides are linked. One unit anomeric carbon is blocked, but second unit anomeric carbon is free. And if second unit anomeric carbon OH is free, then definitely this is reducing. So this is a reducing sugar, right? This is a reducing sugar. Reducing sugar. And this will reduce tolerance and failing. If someone is asked, tell me the nature of this interglycosidic linkage, so you have to decide with the anomeric carbon. So this is beta. So this interglycosidic linkage here, it is beta. It is beta, right? So interglycosidic linkage is beta, right? So this is reducing sugar because this anomeric OH is here free, because this is free. Okay. Now this question, all of you should do this question. This is for you, it is homework, right? Do yourself. Now I'm explaining this. This is sucrose, table sugar. This is glucose unit. This is fructose unit. First you do numbering, identify 1, 2, 3, 4, 5, 6, right? So see, in this molecule, sucrose molecule, this unit is glucose. This is glucose, and this is fructose. Fructose. This is carbon number 1. And you know, in the structure of glucose and fructose, this is carbon number 1 of fructose, this is carbon number 2 of fructose. Means carbon number 1 of glucose and carbon number 2 of fructose joined together, right? So the linkage in sucrose, so I am writing some facts about sucrose. Sucrose, interglycosidic linkage, interglycosidic linkage C1 of glucose plus C2 of fructose. C2 of fructose, right? Now decide the configuration of this anomeric carbon. So this is anomeric carbon here, anomeric, and this carbon number 2 is here anomeric, means both the anomeric carbon condensed with each other in sucrose molecule. So 1 and 5 opposite. So this is C1 alpha, and here 1, 2, 3, 4, 5, right, and 6. So 2 this side and 5 CH2OH this side. So C2 O and C5 CH2OH, if both are in the same plane, then this is beta. So this beta. So all these the I mean important questions from this carbohydrates, that in sucrose which type of anomeric linkage is there for glucose, for fructose, right? So both have opposite. Glucose have alpha anomer, and fructose has beta anomer condensed with each other, right? So now see, uh, is it reducing or non-reducing? So see, anomeric carbon is blocked. If anomeric carbon is blocked, means this is a non-reducing sugar. Non-reducing sugar, right? So sucrose is a non-reducing sugar. Clear to everybody? Okay, good. Now, how to name this, right? How to name this? So you can name this alpha. You can write the name of this alpha D, alpha D gluco pyranucide, pyranucide, right? Now this alpha to beta, right? This alpha, this is alpha, this is beta. Alpha to beta, right? Beta D fructo furanoside. So see, if at some place it is written like this, oocyte and oocyte, means this is non-reducing. Non-reducing. So by simply, if it is written like this, then you can say this is non-reducing sugar, right? So this is the, all about sucrose, right? So this is how to determine, reducing and non-reducing sugar. So this is the structure of sucrose, in fact, right? So in your syllabus, two more structures are there. Sucrose structure is there, so you can copy this structure from here as well. I am not going to rewrite this equation, this structure. Now maltose. Now see the maltose. Maltose. So maltose, it is made up of two glucose units, monomeric units. Monomeric units are glucose, and which anomer alpha D, right? Plus glucose. This is also alpha D, right? And interglycosidic linkage, interglycosidic linkage is alpha 1 4. Alpha 1 4, right? So alpha of one unit and fourth carbon of other unit. So first carbon of the other unit is free, right? So you can draw the structure like this. Now see, this is CH2OH. So alpha means this is alpha, and this OH is down, this OH is up, and this OH is down. So this is glucose. So this is fourth carbon, fourth OH is down, so this will condense like this. But don't bother about this. This is not determine the alpha or beta. This is alpha, right? And see, this is up, and this is down, and this is CH2OH. This is also alpha, so this OH. So this is the structure of maltose, right? This is the structure of maltose. Maltose is a disaccharide having two units of glucose, have interglycosidic linkage alpha 1,4. This is carbon number 1, and this is carbon number 4, right? So this is alpha 1,4 linkage. Anomeric OH is free. This is free. This is free because this is anomeric carbon. This is carbon number 1. This is anomeric, and this is anomeric here. Anomeric. So this anomeric carbon OH is blocked, but this carbon anomeric OH is free. So this is reducing. This is reducing. So maltose is a reducing sugar, right? Now see lactose. Lactose. In lactose, what are the monomeric units? Monomeric units. Galactose, galactose, and galactose beta D. This is beta D plus glucose. This is also beta D. And interglycosidic linkage, interglycosidic linkage is beta of galactose one fourth of glucose, fourth carbon of glucose, right? So this is the interglycosidic linkage, right? So see how to draw the structure. Hmm. So see, this is in glucose, this is down, but this is up, so this is galactose. So CH2OH, right? So now see, This is 1, 2, 3, 4, 5, 6, right? So this is carbon number 1, carbon number 1. So of galactose, and this is carbon number 5, both this CH2OH and OH in the same plane. So this is beta configuration. So this is beta. Now this unit is glucose. So if it is glucose, so this OH must be down, right? Must be down like this. And this is beta. So OH this is carbon number 1, 2, 3, 4, 5, 6, right? So 1, 2, 6, this is glucose unit, and this is beta anomer. So this is beta. Now here interglycosidic linkage will take place between these two. They will condense and remove water and will form the interglycosidic linkage. So see how this interglycosidic linkage form. Water eliminates from here. So right. So this is beta, and for this there is no alpha or beta, just this is glucose unit. So this is beta 1, 4, beta 1, 4, right? So this is the lactose disaccharide, and anomeric OH is free, so this is reducing. This is reducing. See, all disaccharides are reducing. All disaccharides are reducing. Only two: sucrose and trehalose. Right. So we can put a note here that all disaccharides all disaccharides are reducing except sucrose and trehalose. Trehalose. Right. So except sucrose and trehalose, all are reducing. Right. So this is lactose. Now see little bit study about starch. See, starch, the monomeric unit of starch is glucose. Monomeric unit glucose, right? And starch is made up of see linear polymer like this. This is called amylose. And in this linear polymer, glucose units, right? Glucose units, they are linked together by alpha 1, 4. Alpha 1, 4, right? So how to represent this? Um CH2H. So alpha is this. This is alpha, right? So right? So this is alpha, and fourth OH is here. So there is a interglycosidic linkage. Polymeric chain is formed like this, like this, right? Here this is H, this is H. Don't consider here carbon. Do not consider here carbon. Only I have shown like this only. So this is alpha. Again, see here, this will combine H, like this. So this is a linear polymer, amylose, right? Amylose. So this is amylose, 1,4,1,4. So this type of chain will grow in the both the directions. So this is amylose. This will contribute in the starch 20%, right? And another is amylopectin. Amylopectin is basically a branched chain. See, this is amylose chain. This is alpha 1,4, alpha 1,4, alpha 1,4. So this chain is alpha 1,4, and cross linking will takes place with alpha 1,6. Alpha 1,6 means alpha of this and sixth carbon of this, and this type of cross linking will be takes place, and this is called amylopectin. Amylopectin. And amylopectin contributes 80% of the starch. 80% of the starch, right? So this is alpha 1,6. So I'm here showing 1 unit of this, and accordingly you can understand. See here, this will contribute the linear chain. Here linear chain will grow. Here, here linear chain will grow, right? And here linear chain will grow. So, see, this is 1, 2, 3, 4, 5, 6, and this is 1, 2, 3, 4, 5, 6. So this is alpha, alpha 1,6. So cross linking is alpha 1,6, right? So cross linking is through alpha 1,6, and linear combination is alpha 1,4. So this is all about this starch. Now come to the next, that is cellulose. cellulose. Cellulose, this is also polysaccharide, and monomeric unit is beta 1,4, and monomeric unit is glucose, and linkage is beta 1,4. This is a simple polysaccharide because this is what, linear, right? So this is linear. So this you can show like this: beta 1,4 glucose. How to represent this? See, this is beta linkage. I'm not showing other groups. So this is, so see, so this will join like this. This is hydrogen. This will join like this. This is hydrogen, right? And simply this will join. So this is beta configuration. This is fourth carbon. This is beta. This is fourth carbon. So this cross linking. No, this is not cross linking. This is joining of this is beta 1,4. So see, these are the important questions because linkage is very important. If you change the linkage here from beta to alpha, it becomes something else, right? Suppose that if this is alpha, then this is starch, amylose, right? So this is beta 1,4, because in both the cases, if you see, uh, uh, monomeric unit is glucose, then how this cellulose and starch are different? Cellulose and starch are different with respect to this linking. So how they are joined together, that is important, right? So on the basis of this, you can differentiate. So these are the very important questions. So with this, your this carbohydrate is complete.